All right, Big
Come on,
Brian,
Big Man.
let's see what the old host of FTV has up his sleeve.
Come on, Mr. Barometer Man, Mr. Weather Dew, Mr. Check my humidity level, the dew point action, all that stuff. Come on, let's play. I love summertime, man. Come on. Woo! Woo! Yeah! Boy, I love summertime, pal. Getting out shooting some hoops and stuff. It's great.
This is fabulous, isn't it? Nice sunny day, but things can change quick into a thunderstorm.
Hey, no fair, man. I wasn't ready. Give me this baby here. Come on, let's go. I'm gonna go for this baby. Ooh, ooh, ooh. Ha!
Brian, wait a minute, wait a minute. What? Can you hang on to my car keys for me for a minute? Thanks. Hey, your turn. All right, 3-0. My lead.
Give me this ball. Let's go downtown, buddy.
Hey, we better get going. It's starting to rain.
Since the rain kicked us out of me beating you in basketball, I'm going to beat you in a game of cards.
Let's just get the cards shuffled.
Okay, I'm going to
first
shuffle these
of all,
cards.
shall we?
I got to shuffle these cards. Just let me shuffle. I can shuffle.
Brian.
Sorry.
don't you
Well,
let me
maybe
do
you
this?
better shuffle the cards this time. But I do have a question for you, Steve. How come it doesn't always thunder and lightning every time it rains?
Oh, Brian, that is a long story, and I tell you what, I'd rather just play some cards because the storm's gonna come and go. They always do in the summertime.
Oh, but I hate that. When every time that happens, you know... You know, I just want to know why that happens, because maybe I can talk to somebody about that to fix it so that when I do want to go outside, it will be nice.
You know, Brian, let's just play some cards. I mean, in the summertime, these thunderstorms tend to develop. They come and they go, and we'll be back outside in no time.
Whoa, that was close. Whoa! Steve, what happened to the lights?
Hey, sometimes the lights go out during a thunderstorm, Brian.
Well, what should I do?
Well, don't you have a flashlight?
I'll try and find one.
Hey, Brian, I'm up. Hey, what are you doing looking at my cards?
Oh, hey, sorry. Hey, you know, with all this thunder and lightning and everything, I know someone exactly who can help us out
I
with this.
told you, I'm taking the day off. We're playing cards, and then we're going right back outside.
Not you, Thunderbolt Man.
Yeah, right.
Yeah, Thunderbolt Man. He's the greatest. He flies through the air, he's a superhero, and he'll tell us all about it.
Well, why don't you just give him a call?
Hey, you don't believe me? Check this out. Hey, Thunderbolt Man! 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 I'm shot! Told ya!
Hey, I'm Thunderbolt Man. I'm here to answer any questions you have about lightning.
Wow, can you tell us how it's formed?
I can tell you about that in a flash. Thunder and lightning tends to occur in the biggest thunderstorms. Once strong storms grow to a certain height, the cool tops of the storm collect chunks of ice that have a positive electrical charge. The heavier drops of water in the cloud drift to a lower portion of the storm with their negative electric charge. As the storm drifts over the ground, the negative charged cloud base creates a positive charge on the ground. At some point after millions of volts accumulate, a liter of electrical current begins to form between the cloud and the ground, or between the cloud and another cloud, or between the bottom of the cloud and the top of the cloud. Once this electrical path is completed, a bolt of lightning appears and all the energy is released. This electrical discharge becomes visible as a flash of lightning, producing the familiar sound of thunder that accompanies all lightning flashes. Because air expands when it's heated, the heat produced by this rapid, very intense process of making lightning literally causes the air around the bolt of lightning to explode with the sound of thunder. Because the speed of light is faster than the speed of sound, your eyes will see the lightning before you hear the thunder. If a storm is right overhead, the sound of thunder will be extremely loud. If the storm is far away, the sound of thunder has a distant rumble. You can use this knowledge to determine the distance of a thunderstorm. If after you see a flash of lightning, you count the number of seconds before you hear the sound of thunder and divide the number of seconds by 5, you know how many miles away the thunderstorm is. For example, let's say you see lightning. Then count 5 seconds before you hear thunder. Divide 5 by the number of seconds, in this case 5, to discover the distance of miles. In this case, 1. Needless to say, with over 44,000 lightning strikes hitting the Earth every day, people and property are both at risk. That's why when severe thunderstorms develop, you need to seek shelter immediately to protect yourself from the hazards associated with lightning. Although 2 out of 3 people struck by lightning fully recover, usually these survivors were not struck directly. Most are injured when the electricity jumps from a nearby object, like a tree. Those that are struck directly usually don't survive. Based on that, it's nice to know that your chances of being struck by lightning are slim, about 350,000 to 1. However, one unlucky park ranger in Virginia has been struck by lightning 7 times. The Empire State Building in New York City is struck by lightning more than 20 times each year.
Get in! Out! In the window! Hey, look out!
So what should you do to protect yourself against lightning? Sorry. You should always stay indoors during a thunderstorm. Even though the temptation may be to go outside and watch the thunderstorm, you must remember to stay indoors because you must remember how dangerous it can be.
I really got a charge out of that guy.
Oh, go fly a kite. Hey. Oh, Steve, with all this wind and everything now, I tell you, I would just love to get outside and fly my new kite.
Yeah. Wait a minute.
What?
Didn't you learn anything?
Huh?
You don't fly a kite during a thunderstorm.
Oh, okay.
Ever heard of a guy named Ben Franklin?
Yeah. I've heard
Check
of
out
it.
the encyclopedia here.
Okay. Oh, Ben Franklin. Oh.
Check this guy out.
Okay.
One of the first people to study lightning was the early American leader Benjamin Franklin. Franklin, a scientist with a strong fascination for weather, long suspected that lightning was really just another form of electricity. Even though scientists knew very little about electricity in Franklin's day, they understood that electricity could travel through metal. Now, if lightning was electricity, Franklin thought, then it too would have to travel through metal.
Indeed, of the smartest man
Now,
flying.
in 1752, Franklin proved his theory by conducting a simple but very dangerous experiment. Franklin flew a kite during a thunderstorm using a metal wire instead of string. At the end of the metal string was a silk string with a key on the end. When lightning struck the kite, it traveled down the metal wire, jumped over the silk string, creating a spark once reaching the key. This dangerous experiment should never be repeated. The results could be deadly. Did you also know back in the 1700s, people used to think that they could repel lightning by ringing a church bell? Since lightning tends to strike tall objects, church towers frequently become an easy target. During the 1700s, lightning struck more than 375 churches in Europe, killing at least 100 bell ringers. Needless to say, these statistics quickly dispelled any myth about using church bells to chase away lightning.
Brian, hey, wake up. Wake up.
Huh. Boy, it's kind of weird that they were in a bell tower and everything, isn't it?
Foolish, but that's what they thought back then.
Man, is this storm ever going to end? Oh, man, is this storm ever going to go away?
It's going to take a while, I'm afraid. We're stuck inside for a little while.
Stuck inside all day. Can't
Hey,
believe it.
What's that, by the way?
Ah, that's just my transporter. My transporter! Yeah! Hey, this can take us anywhere we want to go, like maybe the zoo or I know, the science museum to learn about all this electrical stuff that's happening in the sky.
Great idea, but if I'm going there, I I'm taking the bus.
No. Have I ever let you down before there, Steve? We'll just dial in Science Museum and...
Yeah, let's just beam on down to the old Science Museum, Brian, just like they do in Star Trek.
Here we are, pal. Take a look around.
How'd you do that?
Magic,
Give
buddy.
me that thing.
Hey.
I got a guy I want to show you.
Hey.
Hey, Jay, how are you?
How are you?
I'm doing just fine. This is my friend Brian.
Hey, Brian.
Brian.
Nice to meet you.
Nice to meet you.
Down here at the Science Museum, where magically Jay will show us some interesting experiments about lightning, electricity, and how all this stuff works, Brian. This is the guy to have.
Cool.
I hear you guys are interested in sparks.
Yeah, we're interested in lightning, that's for sure.
In lightning. I got a little spark machine here. This is just a power supply and running some electricity from out of that power supply. Now I've got a piece of metal here, and I take the piece of wire and connect it to it, and we get some quite a few nice sparks. This little device here that's spinning around here works with electricity, and you can tell that from the sparks, but it also works with this other little disc. If I take that little disc out of here, it slows down and stops. I've got a second magnet here, and if I put it just right, I can make that motor speed up.
Hey, look at that.
Whoa.
Or if I turn it over, the motor comes to a stop.
Whoa, look at this. This is pretty cool. How's that work?
Hey, ask Jay.
Hey, well, we got a couple of magnets there. Now, how do you think they're faced? Are they two north poles or two south poles, or a north and a south?
Well, they're definitely two north poles, I think, Jay.
I think you're probably right, because it's those two north poles that would push each other apart, and if it was the north and the south, they kind of stick together. Here we've got a motor that actually is the same kind of motor that you use to start your car. You take this apart, see there's a magnet that's curved around here, one magnet there, that's a north pole magnet, and then down here we have a south pole magnet, and in the middle we have a whole bunch of wires, coils of wires and a few bearings and stuff like that. If I put those in, and now I take my electricity from my battery, put it up right against the contacts. We've got the motor to run to start your car. The whole thing works with north and south poles. And electricity creates them, and they move apart from each other or they move towards each other. And that's how we get motion out of electricity.
Hey, pretty cool, huh, Brian?
Yes.
Hey, let's take a tour of some other stuff down here at the Science Museum. Appreciate it, Jay.
Well, thanks, Steve.
You bet.
Great to see you. Nice to meet you, Brian.
Hey, Steve, what's this thing?
Haha, check this out, Brian. Homemade thunder and lightning.
Whoa, how does that work?
Well, we've got two wheels. They're spinning in opposite directions, building up all that positive and negative energy, just like we talked about in the thunderstorm cloud.
Yeah.
And when enough energy is created, it's released in the form of this discharge called a lightning bolt.
Oh, cool.
Hear that noise?
Yeah.
Just like thunder, but not quite as loud.
Gnarly.
Let's check something else out.
Okay.
Hey, wait till you see this, Brian. Check this out.
What is it?
More lightning. What? Positive, negative charges, but this time across from each other, just like in a cloud. Now, you can have lightning from the cloud to the ground, but you can also have it from cloud to cloud, as in this case. So positive, negative charges attracting.
So imagine this is like a cloud, and that's how lightning happens from cloud to cloud.
Hey, you're catching on.
Yeah!
Come on, Brian, we got to get going.
Oh, what's your hurry, man?
I got work to do at the station.
Oh, okay, here we go.
Brian! 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 Hey, Brian, where'd you go? Brian! 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 This isn't funny, Brian! Come on, Brian! Brian! This isn't funny! Come on!
Okay, I'll bring you back.
Hey, thanks a lot for leaving me over there. What are pals for?
What, I don't understand it. It didn't quite work right.
Yeah, I think you were in complete control. Let's put this toy away before somebody gets hurt, but I got something else.
Hey, balloons, cool. I love balloons.
Pretty fancy, huh?
Yeah.
Take this balloon, rub it on the wolf sweater, and you got a new hairdo.
What? Hey, it's stuck to my head.
Just another form of electricity. Static electricity.
Weird. It's like stuck up there.
You try it. Pretty neat, huh? Great. That just isn't fine. Hey, there's other stuff you can do with balloons, too. Let me show you.
Okay.
Here's the deal, Brian. First of all, you need a couple of balloons.
Okay.
And some hot air. Brian.
Ah, funny guy. Okay, I'll show you.
Here, give me that.
Oh.
Now we need some string.
Hey. Hey.
Perfect. There you go.
Steve.
Hey, Brian, give this a try. Rub those two balloons on your shirt. You're creating like charges.
Hey, they don't want to go together.
Now you add a piece of paper in between, and they'll stick together. We've added a positive charge to the two negative charges.
Let's see that again. Wow, so opposite charges attract and like charges repel.
Exactly.
Well, Steve, how does static electricity, like, get to my TV and stuff?
Ah, that's a different kind of electricity, Brian, but that's a good question. And one for our old friend,
Mr. Robot.
Hey, you guys have a question about electricity? Come on over.
Hey, Mr. Robot. As a matter
Hey.
of fact, Brian did have a question about electricity and how it powers things in your house.
Well, type it in.
Let's take a look at electricity / power.
What we have here is a little safety awareness program here from Northern States Power Company to the dangers that could happen outside with the wires coming down, trees. These are what we call high voltage rubber gloves, okay? And I guess I want to get it straight, kids, that these are no glove, and for the adults, these are not like any gloves that you have at home, all right? They're a special rubber glove, 100% pure rubber. There's no impurities in it, all right? When I turn this on, what I like to do is have you watch these wires. And as you can see, when I turn that switch on, those wires look the same off as they do on. That's why you have to assume every wire has electricity in it, okay? High voltage makes conductors out of almost everything. And here I have a little tree branch, okay? And of course I can show you how electricity can go through a little tree branch. And of course it goes in the top and out the bottom. We don't want you climbing trees or building tree shacks near these power lines, because that same danger could be that you're up in that tree somehow or another, you make contact with that line, and I guarantee you that at the very least you're going to wind up getting injured. And we don't want that to happen. This is a piece of the power line that secondaries that come from the power pole to your home, okay? Now as you notice that these two black coated wires, they've got an insulation on it, but that is not good insulation, okay? It's what we call weatherproofing. Now say for instance a kite is flying maybe a couple 3 football fields away or whatever, and it drops onto the power line, and you or your child is hanging on to that kite string, I guarantee you that somebody's going to wind up getting injured or killed. Now, I just want to show you that a wire come down, it could be laying like this, all right? Laying down on the ground, no sparking, no arcing. I call that guy the sleeping giant. You never want to wake him up, leave him alone. How far should you stay away? As far as you can. And in conclusion, I've showed you a few safety tips near power lines. Don't be afraid of electricity, but respect it. This is Jim from NSP. Have a happy and safe summer. Thank you very much.
Wow, those are all good things to know around power lines and things. Pretty cool. But I got to tell you, Steve, I feel so cooped up in here. I just got to get outside.
Hey, wait a minute, Brian. There's some things you ought to know.
Oh, I know. I'm going to ride my bike. Yeah, that'll be fun.
Wait a minute, Brian. You shouldn't be out in a lightning storm, let alone on a bicycle. The metal acts as a conductor for lightning.
Oh, well, fine then. I'm going to go play me some golf.
Stop, Brian. Playing golf is the last thing you want to do in a lightning storm. The club or a bat could act as a lightning rod. And we don't want that.
Well, fine then. I'm just going to sit here under this tree and wait for the storm to pass.
No, Brian, you don't want to be under a tree during a lightning storm. Trees are the tallest objects in the area, and lightning will tend to strike it first. And you don't want to be under there then.
Well, fine then. I'm just going to go inside.
What? During a lightning storm, you should go inside. But don't take an umbrella. It's a lightning rod, just like a golf club.
Oh man, you can't do anything outside when there's a lightning storm. But you know what? Inside you can do a ton of stuff, and I'm gonna call some friends.
No, Brian, you don't want to make a phone call during a lightning storm. A lightning strike could travel through the phone line and zap you. Zzz.
Well, if I can't talk on the phone, I'm gonna eat a chili cheese dog from the microwave, yeah.
No, Brian, not even in a microwave. You don't want to use any appliance that uses electricity. Anything that's plugged in can be dangerous. That means microwaves, refrigerators, televisions, electronic games.
Well, fine then, I'll just take a shower.
No, Brian. A shower is a very dangerous place to be during a thunderstorm. See, the water conducts electricity, making it very hazardous.
Boy, there's a lot of things you can't do in a lightning storm, but those are all good things to know.
That's right, Brian. At least you know you'll be safe. But there are a lot of fun things that you can do.
Hey, take me back to Steve. Whoa, thanks, Thunderbolt Man. Woo, boy. Hey, Steve.
How are ya?
You were right. There's not a lot of stuff you can do outside in a thunderstorm.
I tried to tell you that, Brian.
Yeah, you're right. I mean, you can't use a telephone, you can't use appliances, all sorts of stuff. What
Wait
a
a
drag.
minute now. There's a lot of stuff you can do.
Like what?
Well, you can read, you can draw, you can play games, you can color, you can take a nap, which I'd like to do right about now, too. There's a lot of stuff you can do. Use your imagination.
I guess. You're right. There are a lot of things that you can do. I guess I kind of forgot all the cool stuff if you use your imagination, the wacky stuff you can really come up with on your own.
Hey, Brian, looks like these storms are trying to clear out of here right now.
Hey, cool. We might just get outside yet. Hey, Steve, let's put together this puzzle.
Sure, why not?
I'm sure glad storms don't last forever.
Well, that's the important thing to remember. In the summertime, storms tend to pop up and then disappear equally as fast, so you'll be outside in no time.
But there are some things that we do need to remember in case of a thunderstorm so that we don't get injured, like riding a bicycle. That's a definite no-no in a lightning storm, right?
Yeah, like golfing, because remember the golf club acts like a lightning rod when you're outside playing in a thunderstorm.
Yeah, and when you're golfing or even outside playing, you shouldn't hide under a tree because lightning could strike that tree and it could fall on you, or lightning could go through the tree. Not a good thing.
Oh, and the other thing too, Brian, you don't want to talk on the telephone because lightning, of course, can hit your house or the telephone pole, and the electricity can travel down the phone line and zap you if you're on the phone, just like Thunderbolt Man told you.
Oh, yeah, and Thunderbolt Man also said it's dangerous to use any sort of appliances during a lightning storm, like microwaves or washing machines or things like that. That's definitely a no-no.
Oh, and the other thing too, Brian, is power lines. That's very dangerous, we all know anyway. But during a thunderstorm, those lines can come down, they're still active, and then they're on the ground, which makes them even more dangerous. You want to stay clear of those, period.
Hey, Steve.
What?
Do you hear that? Do you hear that?
Hear what?
The storm. I think it's over. I don't hear any thunder anymore, man. I think the storm's over, dude.
You know what? You might be right, Brian.
Hey, man, we are out of here. We are going to play some hoops, baby.
All right, let's go play some ball.
Yeah. All right, man. Here we go, pal. Alley-oop, baby. Alley-oop, baby. Oh, he threw a brick. Here we go. Woo! Okay, come on, Woolly Bear. Come on, Woolly Bear. Come on, Woolly Bear. Hey! Yeah! Yeah! Yeah!
Would you pick up that? Somebody's going to trip on that rock, Brian.
What? Oh! Oh! Okay.
Thank you.
Okay.
Thank you.
Okay. I see how you are.
Bring that basketball here, man.
Come on.
Shoot the basketball. Oh, come on. Hey, follow.
Woo!
Can't do that.
Hey, there ain't no room on the big man. 10 to nothing. You
Well,
me.
you better write it down, otherwise we're going to forget.
All right, 10. Hey. Yeah. Funny. Hey, give me this ball here. All right.